And today what I'm going to do is I'm going to talk about the innovations what we are doing on the Catalyst 9800 portfolio. But before I go into more details, what I'm going to do is I presented last time in Tech Field Day session about Catalyst 9800. I introduced the Catalyst 9800 portfolio. So I'm just going to take one slide and introduce you again to 9800, just a recap. Catalyst 9800, if you notice, we have appliance 9880, 9840, and 9800L. It can go all the way from 250 APs to 6,000 APs, 64,000 wireless clients. And this is the first time we have decoupled the hardware from a software. That means you can run exactly the same software which you're running on an appliance, also on a private or a public cloud. You can run on ESXi, KVM, Cisco ENCS on a private cloud, and AWS and GCP in the public cloud. You can go to the AWS marketplace, find 9800, instantiate an instance, and manage all your access point on your branches. Same features, same scale, supported on an appliance. But then last time I also introduced 9800 as an embedded wireless controller on Catalyst switches, which means 9300, 9400, and 9500 for our software-defined access deployments. And all supported from Cisco DNA Center for policy, automation, and assurance, and can manage all your Cisco AeroNet and Catalyst Wi-Fi 6 access points. What I'm going to today is I'm going to introduce embedded wireless controller on Catalyst Wi-Fi access points, which means now you can run the 9800 wireless controller on Wi-Fi 6 access points. If you look at it, it runs the same 9800 iOS operating system, iOS XE, which I'm running on an appliance, which I'm running on a virtual cloud. I'm also running on an access point. Now, iOS XE, as you all know, is a very modern, scalable, and open and programmable operating system, which is now running on a Wi-Fi 6 access point and support telemetry. We support all the advanced enterprise-grade features on this deployment, but with no compromise, which means that high availability, software maintenance update, APSP, AP device pack, what features we use to support on the appliances and virtual machine is also supported on this deployment. If you also look at it, all the security features, which is adaptive VIPs, rogue management and containment, umbrella, and ICAP, is also supported on this deployment model. But as I said, it is deployment for enterprise-grade deployments. It has a very flexible management option, which means you can manage it from a mobile app, you can manage it from a web UI, you can also manage it from Cisco DNA Center for multi-site management. But it has an investment protection. Tomorrow, if you decide that these access points need to join the controllers, you can make them join the controllers also. So the flexibility is on the customer how you want to deploy your network. Now, as I said, embedded wireless controller is designed for single or multi-site, small-size deployments. If you want to deploy it on a single office, you can deploy embedded wireless controller using a mobile app or a web UI, and a set and forget. You just deploy it, and you can monitor and manage it from your mobile app. But if you want to manage your distributed office and distributed enterprise, you can do the same. All your small sites with less than 100 AP deployment, you can do it with embedded wireless controller on Wi-Fi 6 access point. And on a bigger site, which is campus, you can deploy 9800 appliance or a virtual machine. And using a Cisco DNA Center, with a single pane of glass, you can manage your multi-site wireless deployment. Now, I just want to show you a portfolio where this embedded wireless controller is supported. Embedded wireless controller is supported on all the Wi-Fi 6 access points, starting from 9115, 9117, 9120, and 9130. All the Wi-Fi 6 access points, what we have released in last 1 year, it supports embedded wireless controller. Now, which all access point it supports as a client serving APs, right? So you can have your embedded wireless controller running on a Wi-Fi 6 access point. You can also serve the clients. But if you have your older access point, which is Wave 2 access point, which is 1800, 2800, 3800, and outdoor access point, they all can join embedded wireless controller running on a Wi-Fi 6 access point, which means a truly controller-less deployment. You are deploying a controller on a Wi-Fi 6 access point and managing your existing Wave 2 access point to serve the clients. Now let's go a little bit more details about embedded wireless controller. As I said, this is made for distributed enterprise deployment, and we have made sure that there is no compromise on the feature sets. So we are again built it on the 3 pillars of excellence, what we built 9800 appliance controller, which is resiliency, security, and intelligence with an IT simplicity. So let's go to a little bit more details about all the 3 pillars. By resiliency, what we mean is that we can have an active controller, and a standby controller running at the same time on 2 different access points. Which means if your active access point goes down due to any reason, which is running a controller, the standby controller is already available on one of another Wi-Fi access point and it takes over the network. Which means there is no downtime. If your active goes down, standby takes over. And this active standby election will keep going on till the time you are left with the last access point in the network, which will be your active access point. But all the enterprise gate features, as I said, software maintenance updates, your AP service pack and device pack, which is supported on 9800 appliance and virtual machine, is also supported on this deployment. Which means if you hit a vulnerability on your controller, you can put a patch onto the controller. You don't need to upgrade the entire controller on an access point. You can just put a patch and the issue can be taken care of. But if you hit an issue on one of the access points due to some reason, you can also put an AP service pack on those access points. You just put an AP service pack on the controller. Controller intelligently finds it out which access point needs a patch and pushes that access point to that patch to that access point. But security being on top of the mind, this is also very important for all enterprise gate deployment. Security is always on top of the mind. So we have made sure that all enterprise gate security is available on this deployment, which includes adaptive VIPs. Which means if there is an attack happening in your network, it could be DOS attack or association attack, the controller which is running on an access point can detect the attack happening and will be able to report it and you can contain it. It also gets integrated with Cisco Cloud Umbrella, which means you can whitelist or blacklist the URLs which you do not want to allow in your deployments. And then again, as I said, it is intelligent with IT simplicity, which means you can manage this deployment using a mobile app, web UI, Cisco DNA Center for multi-site deployment, and also from a programmable interface. You can use netconf and YANG model to manage this deployment on multi-site if you have your own tools, which is using the netconf and YANG models. Now let's go a little bit more details about redundancy and high availability. I was talking about resiliency, right? That's very important for enterprise gate deployment. Does not matter what happens, your network should always stay on. So let's discuss about how we are doing redundancy and high availability in embedded wireless controller on Wi-Fi 6 access points. So now if you look at it, there are 2 different kinds of deployments which can happen, or let's say events which can happen. And unplanned events, which means you have no control, all of a sudden because of some power issue or a vulnerability, some access point can go down. So that's an unplanned event, you have no control on that. And then there is a infrastructure updates, which means there is a vulnerability in the software and you have to upgrade it. So how you can do it without impacting any downtime? Let's discuss about it. So if you look at this deployment, there is an active controller running on one of the Wi-Fi 6 access point, and then there is a standby controller running on another access point. So at given point of time, there is always active and standby controller running on Wi-Fi 6 access points. Now what happens if your active goes down? The standby becomes an active. And one of the existing access point now became a standby. So this election will keep going on till the time you are left with the last access point. And if you look at what happened, because it's active and standby all the time present, you are having always on network, which means your AP will continue to work because there is always active and standby controllers. You will always have clients, which means your traffic will continue to pass because again you have 2 controllers all the time. And then you have always on services, which means your traffic will continue to work. Let it be voice traffic or a video traffic will continue to work if there is an active and standby switchover at any given point of time. Now let's look at how this active and standby election happens, right? Because it's important to understand how are we electing the standby when you have multiple APs in your network. So there is an algorithm which runs where the active controller decide which will be the standby controller in my network. And as and when APs join, the active controller decide and sends the priority to the access point which is joining and which can be a standby controller. Now the algorithm runs in such a way that if manually it's been configured that which access point will be my standby, that will take the highest priority. But if somebody has not configured the standby controller, then we decide based on the access point model number. If it is 9130, that's top priority because that's the biggest access point what we have. Then 9120, 9117, and 9115. So if all are 9130s, then based on which access point has joined first, based on the join time, that becomes the standby controller. So election procedure is very simple. There is an active and standby all the time. And when you log into your web UI of your active controller, you will be able to see which access point is active and which access point is standby. And you will also see the mode is SSO, which is stateful switchover, because there is active and standby controller running all the time. And at any point of time, you can log into the web UI of an active controller, and you will see that who is your standby controller. Now let's look at how do we do the seamless software update. Now this is the innovation what we have done, and it is possible because of iOS XE, which is a modular and multi-threaded operating system, which is running on an active controller. And let's say you hit a vulnerability. What do? We give you a patch. You put the patch on an active controller, and that patch is sent from an active to the standby controller, which means that as and when you put the patches, whichever is your standby access point, which is running a controller, the patch is automatically transferred on that standby controller. And the issue is taken care of. You don't need to upgrade the entire controller image to take care of that patch. So very simple, which means that once you certify an image, you can stay on that certified image. You don't need to upgrade an image all the time if you're hitting a vulnerability. But what happens if an access point hits an issue? If one of the access points hit an issue, we can give you AP service pack. Now you put the AP service pack on an active controller. Active controller install that AP service pack on that particular AP which has an issue, which means without upgrading the controller, you can take care of vulnerability on the access points also.
But on the access point side, during the update, there is a service interruption, yeah?
Yes, but the way we handle it that once you put that patch on that access point, we intelligently move all the clients from that access point to the neighboring access points.
So it is taking care that not multiple access points are updated at the time he has a sequence and doing this
exactly
one after another. Okay.
So when you put the patches get to all the access points first in the flash, but before rebooting, we do it in a staggered fashion, which means we reboot an access point which has least number of clients. And if there are still some clients, we move the clients to the neighboring APs. And when there are no clients on an access point, we reboot that access point first. And in the same staggered manner, we update all the access points with the patches. So that way, with no downtime, without upgrading the software image, you can take care of the vulnerability in your AP on the AP side. But then what we have also done is, what if you want to make a new AP hardware join the controller? There is something called as AP device pack. Now let's take an example. We have 9120, which is running as an active controller. And we introduce new AP, which is 9130, which is not supported in the software which active is running. Now you have to upgrade the software to make the new AP model join. But instead of upgrading the software, what we can do is we can give an AP device pack. You put that AP device pack on an active controller, and a new AP hardware can join the controller, which means, again, there is no downtime. A new AP can get introduced into the network, can start serving the clients. Again, it is all possible because of iOS XE, which is running on an active controllers. Now let's look at how you deploy this embedded wireless controller. We'll go through the deployment procedure, how simple it is to bring up this and deploy it in set and forget environment or distributed enterprise deployment. So if you look at it, there are two ways to deploy this embedded wireless controller. The first way is very simple. You have a flat VLAN network. It is unmanageable switches. You cannot go and configure anything. You power on these access points, connect it to those unmanageable switches. They all come up, connect, and start advertising an SSID. No configuration needed, just day zero provisioning from a mobile app or a web UI. You can start serving the clients. Now the cons of this solution is less flexible, because if you look at it, you have a single VLAN. Because it's unmanageable switches, all APs are on VLAN 10. And the SSIDs also will be on a VLAN 10. That means your AP network and your client network is on the same VLAN. But if you want a little bit more flexibility, you can go to the right-hand side deployment where you can have multiple VLANs. Your access points can be in a VLAN 10. And then for your clients, for the guests, for the IoT, you can create different SSIDs and map them to different VLANs. Now, if you look at it, there are 4 VLANs that have been created. VLAN 10 for an access point, VLAN 20, 30, and 40 for your contractor, employee, guest, or an IoT network. The only thing what you need to make sure is there is a trunk configuration from your access point to the first hop switch, so that you can allow all the VLANs where your SSI clients are on those SSIDs. Now, the pros is it's flexible and secure because you have a different VLAN for a different SSIDs, and then you have APs in a different VLANs. The cons is that you have to configure the trunk port. You have to make sure that more configuration goes on the switches. But for simple set and forget, boot it up, all can come up. In day zero, APs can join the controller and start advertising an SSID. Now, there are 2 ways to provision it. One is OTAP, which we call as over-the-air provisioning. And second is called as plug and play, which can be done by Cisco DNA Center. Now, when I say OTAP, it is over-the-air provisioning using your mobile app or a web UI. Let's look at how we do it. So what have we done new in the day zero provisioning in this embedded wireless controller? We have done a lot of innovation on the software side that in the day zero itself, you just take out an access point from the box, power it on, all the access points come in day zero and join one of the active controller. The active controller election also happens automatically. One becomes an active, all the APs join in day zero, start advertising SSID. When they advertise an SSID, they advertise a single SSID called as Cisco Air Provision and the last 4 digits of MAC address of an active controller. So when I connect to it, I know that which is my active controller. Because only single SSID has been advertised, I can associate to that SSID using my mobile and can go to the day zero provisioning and network will be up and running. Or I can use mywifi.cisco.com URL. And when my laptop, when I log into this URL, I directly get the day zero web UI wizard and I can configure the day zero. Simple 4 steps and network will be up and running. The SSID what you want, the VLAN what you want those SSIDs to be. And then no reboot is needed when you do the day zero. So once you do the day zero, you configure your SSIDs, your VLANs, and the security settings, and you save the configurations. There is no reboot needed for an active controller. It's always up and running. And automatically day one settings will start getting advertised. Now let's look at the election procedure which I was talking about. How do they know that which MAC address to be advertised when the election is happening? So if you look at it, we do the VRRP based election. If there are 10 access points booting at the same time, we have to select one as an active. Based on the lower MAC address, we decide who is an active controller, or based on a AP model. If all the AP models are same, we choose the lowest MAC address. And once we decide which is an active controller, all the APs will join that controller and start advertising one SSID called a Cisco Air Provision. And if you see the last 4 digits of the MAC address, AAAA, that belongs to the MAC address of my active controller, which is 9120. So there are 3 access points in this example, 9120, 15, and 17. Based on the model number, 9120 has been picked as an active controller. It has MAC address A, and A, the last 4 digits. All the access points start advertising this SSID with that AAA as a MAC address. So I know which MAC address is the active controller. Now using a mobile app on the iOS device or the Google Android OS, I can click on a setup. I can click on a configure and I can start operating. Or I can use a web UI also to go to the day zero screens. Let me show you how the mobile apps looks like. So if you look at this is a mobile app, you can click on continue. You get 2 options. One is a setup, if it's a new setup, or you can click on manage if it's your existing setup. Once you click on a setup, again it asks you 2 options. Do you want to connect to the SSID, Cisco Air Provision, the MAC address? You can just connect to that SSID and start provisioning it. Or it gives you a second option called as scan the QR code. All the access points at the back will have a QR code scan. So you can take the picture of the QR code scan and automatically you start configuring those access points. If you look at the next page, you go to the username and password, enter it, and then you will start seeing the first landing page of your mobile app. A very simple mobile app configuration option. It shows you the SSID, it shows you the number of access points, it shows you wireless and wired clients. It also shows you number of rogue clients, which the embedded wireless controller finds in the network, if there is a threat. And then it also shows you interferences from a non-Wi-Fi devices. And on the right-hand side, you can also see the top 10 applications usage on your mobile app in that wireless network. The employees are using what are the top 10 applications, how much traffic is being passed for that application. So a very simple mobile app which gives you entire day zero provisioning and management to this deployment model. Now this is the example which I was trying to show, Cisco Air Provisioning, the MAC address, what is being advertised. You can use your client to connect to that, give the password as a password, that's the default password in day zero. Once you log into that, you go to mywifi.cisco.com from the web UI, go and configure the day zero. Or as I said again, with your mobile app, you can go through the Express wizard and configure the entire network. Now let's look at for multi-site deployment, how does it happen? If you have distributed enterprise, multiple sites where you're deploying this access point, how do I manage that? I can manage that using a Cisco DNS Center plug and play. Now how does it happen is, let's say you have an EWC AP, which is your active controller. Then what you have is, you have a DHCP server and you have a Cisco DNS Center. From the DHCP server, the first step, when you try to contact and get an IP address, you can return the Cisco DNS Center IP address as an offer. Once I get an IP address of Cisco DNS Center, EWC AP will try to connect the PNP server on the Cisco DNA center using an HTTP and install the certificate which is available on the Cisco DNA center. Once I have a certificate, I'll connect to by an HTTPS and go to the DNA center in an unclaimed state because I don't know which site this access point belongs to. And now you can go and decide this access point belongs to site 1, this access point belongs to site 2 or site 3 or site 4. Like that you can configure thousands of sites and have this embedded wireless controller running on every site. So a very simple plug and play. By default, when it powers on, it do a PNP, and you can deploy it on multi-site deployment from Cisco DNA Center. As I said, step 0, you get the option 43, get the DNAC IP address. Only active controller or an active access point talk to the DNA Center and get those details and start talking to DNA Center. And once you do the PNP, you can claim it to the site. And the basic configuration like a syssoc server, the CLI, the serial number is pushed. And then in the step 2, you can do the day 1 configuration, the RF profile, the fine tuning, the SSIDs. You can do in the step 2 and configure all advanced configurations. Now the last section which I want to talk to you is that how can you convert this embedded wireless controller into a regular CAFAP access point if you want to make it join to a regular appliance-based or a virtual controller. So very simple process. You download an EWC AP software from the cisco.com. It's a zip file, unzip it. You will find a controller image and an AP image. And then once you put that image on your TFTP server, you just have to execute one CLI. You get to the DHCP server, get an IP address. Once the AP has an IP, I can give this CLI, AP type EWC, and give the TFTP server detail. It downloads an image. And the regular CAFAP AP can be converted to an embedded wireless controller AP if it is Wi-Fi 6. And then this becomes your master AP, which can start serving rest of an APs. Which means if you have a regular access point, you can convert it to a EWC AP also. But what if you have an EWC AP, and now you want to convert it to make it join back to the controller? Most of the customers do it because of 2 reasons. You do not want this EWC AP to elect in active or standby. You want it a regular CAFAP AP. Or you want to make it join to your appliance or a virtual controller. You can convert it back to the CAFAP AP with just one single CLI called as AP type CAFAP. You go to the AP, give this CLI, the EWC AP can be converted to a regular CAFAP AP, which can go and join your appliance-based or a virtual controller. You can also do it from the web UI. The web UI gives you 2 options, convert to EWC or convert to a CAFAP. Just click on those buttons, and you can convert the CAFAP AP to EWC AP or a EWC AP to a CAFAP AP.